Okay, hello everyone. You're welcome to this video. I remain your tutor, Mr. Life Changer. In this video, I'm going to be answering some waec past questions on periodic table. As you know, periodic table is one of the most important aspects or questions you're going to be seeing in your theory waec. Okay, and I will be doing same for other topics. Now, the first one here says, consider the following table. Which of the elements? Okay, these are the elements. We have elements here. We have atomic number, and we have mass number. Okay, so which of the elements is a halogen? Is most likely to be attracted by a magnet. III belongs to group 1. IV would readily form an ion with a double negative charge. Okay. What type of okay, we have a lot of questions here. How many neutrons are in Q and blah 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 blah. Okay, so let's go now. In understanding this, first of all, for me to answer a question like this, I usually reduce the atomic number, write the electronic configuration. It can reveal a lot of these things instead of cramming. For example, the configuration for this is 2, 7. The configuration for this is 2, 8, and 3, right? 2 plus 8, 10, 10 plus 3, 13. The configuration for this is 2, 8, 6. The configuration for this is 2, 8, and 9. The configuration for this is this is 24. 24 means it's more than 20. That's definitely a transition element. I think it may be proper using 2, 8, 8, 2 plus 8 is 10, 10 plus 8 is 18, 18 then plus 6, okay? Now I'm making it this. Even though it is proper, even if you write it as 2, 8, 14, because in the third shell it can be up to 18, but you know, this is what we have. Now, we can now answer the questions. The first one says, which one is a halogen? Halogen is a group 7 element. So I'm going to look which one ends with 7, which valence electron ends with 7, which is J. So the answer to this question is J, because J has a valence electron of 7 valence electrons. Valence electron simply means electrons that are in the outermost shell of an atom. Now the second question says, which one is most likely to be attracted by a magnet? Only metals are attracted by magnets. Okay, that is very important for us to know. So the metals here are this, which is 13. That's Q. Another metal here. Okay, that's the only one here. Then the transition metal also, which is Y. Now, you should know that metals have valence electron of 1, 2, and 3. So metals are group 1, group 2, and group 3 elements. And one of the things that characterizes metals is that they attract electrons. Okay? Now that is very, very important for you to know. That can be attracted by a magnet. Okay, so and transition metals, can also be attracted by a magnet. So that's why we have Q and Y. So the next one says, which of them belong to group 1 element? Group 1 element simply means that anyone whose configuration ends with 1. Oh, sorry, this should not be 289. I made a mistake. There is no 289, it's 2881. It's still between the group 19. So I'm also supposed to add that to the metals X. That is X here, you know. Sorry for that earlier. Then the group belongs to group 1 element, that's it, which is X. So X belongs to group 1 element because it has a valence electron of 1. Okay, then the next one says, would readily form an ion with a double negative charge. When you have a negative charge, for an atom to form negative charge, it means it needs to gain electrons. So we are going to look for the one that can gain 2 electrons to form negative charge. So looking at this, we can see that this one is 1. No, this one is a metal. No, this one is 2. Can you see that? So you can take 2 electrons from here and this will need 2 electrons to become stable, to become octet, for the valence electron to be 8. Once the valence electron is 8, you say that it has a stable configuration. So this one, bears that. It needs to. Now, I know some persons might want to think about this one here, but no, these are transition metals. That's why I had a problem writing it like this, because they are transition metals. The best way to understand transition metals is by using the other form of electronic configuration, where we can say argon, this is 38, then we have 3d and 4s. I think 4s2, that makes it 20, then 3d 6 or 3d4, that makes it 24. Okay, so which is going to be AR. Actually, the way we write this is 3d5, then 4s1. Now, please, this AR here represents argon. It is 1s2, 2s2, 2p6, okay, 3s2, 3p6. So instead of doing all of this, you can just represent it with argon, especially when you are naming transition elements. Then the rest should be shared between 3d and 4s. That's how to name transition elements. But I want to say this, you're going to wonder why I wrote it like this. That's because if you want to write the configuration of a transition element, as long as the combination is enough to make this half filled or fully filled, you will do that first before you fill this up. So half filled d orbitals can take 10 electrons. So half filled means d5, fully filled means d10. Okay, so since this can fill this half filled, I will fill it first before we put the remaining one here. This only happens whenever you have something like this, maybe 4 2 or when you have like 5 6 7 electrons to share between these two. But that's by the way. Okay, so the next one says would readily form an ion with a doubly negative charge. Okay, I think I've already answered that. That one is in R. That one is R. So I'm going to come here and write R because it has 6 valence electrons. Now the next question says which type of bond would exist between J and X when they combine? Okay, let's see. J and X. J is a non-metal. It needs only 1 electron. X is a metal. Okay, so any bond that is formed between a metal and a non-metal is an electrovalent bond. Remember, this is a non-metal because the valence electron is 1, as against this one that the valence electron is 7. So I'm going to come here and say it is an ionic bond. You can use the word ionic or you can use the word electrovalent. Okay? Now, the next one says, how many neutrons are in Q? Now, of course, you should know that neutrons, number of neutrons is always equal to mass number minus atomic number. Okay, I will say M minus A. So the mass number for Q is 27. The atomic number for Q is 13. So 27 minus 13 is 14. So the number of neutrons is 14. So I'm going to come here and write 14, right? Now the next one says, write the formula of the compound formed when R combines with X. So let's see, R and X. R is a non-metal, valence electron is 6. X is a metal, valence electron is 1, is a metal. So the bond between a metal and a non-metal is definitely an ionic bond. And generally the bond, this is ionic, but the bond between two non-metals, kindly note this, the bond between two non-metals, a non-metal and another non-metal, is a covalent bond. Okay, now dative bond is also between two non-metals, but the difference is that one of them must be electron rich, the other one must be electron deficient. Okay, so but that's by the way. Now the next question now says, state the element which exists as a diatomic molecule. Only non-metals can exist as a diatomic molecule, like the group 1 element, chlorine, bromine, the group 7 elements, the group 6 elements, the group 5 element like nitrogen are all diatomic. So let's look at that. Diatomic, this is fluorine actually. So this is diatomic, Okay, and no, this is a metal. No, this one also is diatomic. Okay, this is oxygen. Oxygen has, oh no, this is sulfur. No, sulfur is not. Sulfur is not diatomic. Okay, this is a metal. This is a metal. So the correct answer is just J. J is diatomic. You can have fluorine. All group 7 elements are diatomic like this. Okay, then group 6 elements, oxygen is diatomic, but sulfur is not diatomic. Group 5 elements, nitrogen is diatomic, but phosphorus is not diatomic. So these are the diatomic elements. You can also add hydrogen. Hydrogen is diatomic, right? So please kindly note this. These are very important thing for you to know. You may ask, what is sulfur? Sulfur is actually S8. Sulfur is polyatomic. The same thing with phosphorus, P4. Phosphorus is also a polyatomic element. Okay, that is very important for you to note. Then the next question here says, select the elements which belong to the D block of the periodic table. The D block, I already mentioned that these are transition elements. That's how you define a transition element. They are in the D block of the periodic table. That means they have the presence of d orbitals. And the only one that does that, I already explained something like that here. The answer is Y. Y is a transition element. Once you get to 20, from 21 and from 21 to 30 are what we call first transition elements. So they are transition elements. So I'm going to come here and say that the answer is Y. Okay, so thank you very much. We are going to continue in our next video for the periodic table. Thank you.